Thanks for watching the video. I'm Xiaofang Qin, the founder of GI Biopharmic. In this video, I'll give my explanation on how changes of gut microbiota in modern society may cause inflammatory bowel disease, or IBD, and contribute to many other health problems associated with dysbiosis of gut microbiota. As we know, many diseases increase dramatically along with industrialization and modernization. This slide shows changes in incidence of IBD, including Crohn's disease and ulcerative colitis during 1930 to 2010 at different locations around the world. Here shows the increases of other diseases such as asthma, multiple sclerosis, and type 1 diabetes in the last century. At present, the cause of dramatic increase of these many diseases is under intensive study. Here, I would like to give my explanation that you may easily understand through this video. Many studies in recent years revealed that dysbiosis of gut microbiota has played a critical role in the pathogenesis of IBD and many other diseases. This dysbiosis is mainly manifested as decreases in both abundance and diversity of gut bacteria. Studies further revealed that many of these diseases are related to increased intestinal permeability, the so-called leaky gut, thus increased infiltration of bacterial and other toxins from gut lumen, and sustained chronic low-grade inflammation of the body. So the key question would be, what made the gut become leaky? My explanation is that impaired inactivation of digestive proteases in the lower gut due to decrease in gut bacteria may be the primary cause. Under normal condition, digestive proteases such as trypsin and chymotrypsin become hardly detectable in the large intestine. However, large amounts of digestive proteases can be found in the large intestine of germ-free animals, suggesting inactivation of digestive proteases in the lower gut depends on gut bacteria, which is corroborated by the fact that large amounts of digestive proteases can also be found in the large intestine of animals treated with antibiotics or even some dietary chemicals such as saccharin, as a result of inhibition of gut bacteria. You may wonder why the high amount of digestive proteases in the large intestine of germ-free animals or in the small intestine that help digestion of protein in diet do not cause damage to the gut. The answer to the mystery lays in the special structure of the protective mucus layer. Mucin, the building block of mucus, consists of a core peptide surrounded by many carbohydrate side chains. Thus can only be rapidly broken down in the presence of both glycosidases, mainly from gut bacteria, and proteinases, mainly from the pancreas. Under normal condition, gut bacteria and gut tissue are separated by a layer of mucus. However, patients with IBD have much thinner and defective mucus layer that allow gut bacteria to contact and get into the tissue. Not surprisingly, IBD patients, such as those with ulcerative colitis and Crohn's disease, also have much higher levels of digestive proteases in the feces, which may have contributed to the rapid degradation of the protective mucus layer, damage of gut tissue, and the pathogenesis of IBD. So a key question would be how digestive proteases are inactivated by gut bacteria. My study suggests that the formation of deconjugated bilirubin by gut bacteria may have played a critical role. My study found that digestive proteases such as trypsin and chymotrypsin can be inactivated by unconjugated bilirubin, but not conjugated bilirubin or bilirubin. As we know, bilirubin mainly comes from heme of old red blood cells, which are further taken up by phagocytes such as macrophages in the spleen. After degradation, heme is released from hemoglobin and further metabolized to bilirubin. Then bilirubin is further metabolized to bilirubin. which is transported and conjugated in the liver and released through bile into the gut. In the upper gut, bilirubin remains in the conjugated form, thus digestion of dietary protein would not be affected. In the lower gut, the conjugated bilirubin is promptly deconjugated by certain kinds of gut bacteria, resulting in inactivation of digestive proteases, preventing their damage to gut tissue. In fact, in many animals such as rabbit, nutria, or tilapia, bilirubin has been the main form without further transformation into bilirubin. These animals are mainly herbivores, while bilirubin has been the main form in carnivores or omnivores such as tiger, rat, or trout. They found that digestive proteases can be inactivated by bilirubin but not bilirubin, suggests that inactivation of digestive proteases by deconjugated bilirubin may be the evolutionary driving force for bilirubin or bilirubin predominancy in animals. I believe the impaired inactivation of digestive proteases by deconjugated bilirubin may be the primary cause for IBD, which I first proposed in 2002. In 2012, I further brought forth a unified hypothesis on the etiology of IBD, including the cause and the mechanism of IBD, as well as the relationship between ulcerative colitis and Crohn's disease. Impaired inactivation of digestive proteases may be also the key event for other health problems associated with dysbiosis or gut microbiota. Here is my explanation as how the dysbiosis of gut microbiota may cause or contribute to the pathogenesis of IBD and other diseases. I believe the decrease of gut bacteria in modern society, along with improved hygiene and inhibition by antibiotics, some food additives, etc., cause decreased formation of deconjugated bilirubin, thus impaired inactivation of digestive proteases in lower gut, which cause damage of gut barrier and gut tissue, resulting in the leaky gut and IBD. While leaky gut also causes increased infiltration of bacterial and other toxins from gut lumen into the blood, leading to the formation or worsening of many diseases of the whole body. Since 2001, I have contacted multiple national and international agencies, IBD professionals and foundations, pharmaceuticals such as NIH, FDA, CDC, WHO, EU, CCFA, Broad Foundation, Merck, Johnson & Johnson, etc., along with series of publications, advocating conducting more research and developing some products, but failed to raise action. In 2014, I left academia and founded GI Biopharma Inc., aiming at developing products targeting protein-inactivated digestive proteases in the lower gut. After years of effort, GI Biopharma Inc. developed the first product, GI-001 Probiotics, as a probiotic dietary supplement, which can be purchased online and following websites. It showed more efficacy than fecal microbiota transplantation, the so-called FMAT, in animal colitis model, and may help replenishing gut bacteria and function. However, as a dietary supplement, I'd like to clarify that this product has not been evaluated by the FDA and is not intended to diagnose, treat, cure, or prevent any disease. More research and development are underway. At present, the cause of IBD and the role of gut microbiota in diseases are presented by the mainstream of research as extremely complex and can only be deciphered by sophisticated approaches such as the multiple omics and the meta-omics, to which I have a totally different view. I believe the primary cause and the root mechanism could be very simple as discussed in this video. GI Biopharma Inc. will continue its effort to find the solution. Hope you may join this effort. Here is my contact information. Thank you again for watching the video.